Okay, so like we've kind of been talking about, eye tracking is of course not a perfect measure, not a totally complete measure of attention, right? Eye movement and attention is of course well correlated, right? A lot of your attention can be determined from your eye movements, but that's not the whole story. Try to think of an example for a minute. So, like we talked about, of course, the fact that you can still get inattentional blindness when people fixated on the gorilla, or that people sometimes notice the gorilla even when they didn't look at it, again, kind of reinforces this idea, or the cueing paradigms. So specifically, there are some issues that can arise with eye tracking is, of course, something known as the blank stare, right? So you've probably all done this before when you're just kind of staring at something blankly. You're not really paying attention to it. You're not really taking it in or thinking about it or doing anything of that sort. You're just staring blankly, right? So the eye tracker would tell you that you're paying attention to it, right? Because you are looking at it, but you might be thinking of something totally different. You might be listening to something. So therefore, it's not, that's an example where it's not exact, the eye tracker is not exactly capturing your attention. Another big one is peripheral attention. So kind of like we talked about with the cueing paradigms. Again, your eye movements are not totally in sync with what you're attending to. You can give more or less attention to things in your peripheral vision, even without changing where you're looking. Another big one, kind of like a blank stare, is of course auditory changes to attention. So again, you might be looking at something or looking all around, but in reality, what you're actually focusing on is something you're listening to, right? That wouldn't be picked up by an eye tracker, of course, right? It's not, the eye tracker doesn't know that you're actually focusing on what you're hearing as opposed to seeing. So the eye tracker might think you're staring at something or looking around for something when really you're just thinking about what you're hearing at that moment. Another thing, kind of like I mentioned before, with how it's difficult to look at differences in kind of really small areas, it can like specifically with letters within a word, sometimes it's not always clear what aspect or what feature is attended within a single object. So for example, let's say you looked at a chair, right? A chair that was in front of you. Especially when it comes to kind of whole aspects of the object, you can't really tell, the eye tracker can't really tell what you're attending to. So you might look at a chair, the eye tracker just tells you you're looking at a chair, but it doesn't tell you, are you really focusing on the color of the chair or the shape of the chair? Both those things would look identical in the eye tracker or in the eye tracking data, right? Like I said, it's typically eye trackers don't work with a very small area of interest. So again, if it's a decent size, like the billboards or the screens, you can get a sense of that. But beyond that, there's not really much you can see. So again, you can't really look at something like individual letters in a word. Okay. I'm going to skip that over because that's going to be part of your assignment. Another thing with eye tracking is something you can look at is actually pupil dilation. So you've probably heard before that pupil dilation is a measure of arousal. So kind of how arousal doesn't just mean sexual arousal. It's like all kinds of arousal. Could be fear, could be liking something, any kind of reaction you typically will see your pupils dilate. So a question we might ask with this, for example, is better arousal associated with better memory? So we could give people a memory test and then kind of, see what words or what objects or whatever stimuli you're using were associated with better memory, right? Were those also higher in arousal? Another question that's often been looked at is, do different types of memory show different pupil dilation? So, for example, this idea that when you recognize something, it just feels familiar to you. Some have argued that versus, say, you recognize something and you remember specifics of the prior encounter. So you see someone on a bus, you say, oh, that's this person from class. There's some research looking at those two different modes of recognition. Do they show different pupil dilation? Another nice thing with eye tracking you can do is look at a more objective measure of effort. So if people are really highly engaged in some sort of cognitive task, and it's really demanding, typically their pupils will dilate, right? And you can kind of imagine how this is a much more preferable measure to simply asking people, although asking people would work in some situations for sure, but asking people, kind of interrupting them in the middle of a task to say, oh, is this hard? I don't know, maybe that's not ideal for your research question, right? Whereas with eye tracking, you can kind of gather that data without interrupting them, right? And again, you always run into stuff like, are they going to be honest? Are they going to tell you how accurately can they report how hard something is? As we know, there's lots of cognitive illusions out there. So eye tracking is great because it can kind of provide a very objective measure of effort. Okay, sorry to cover this. One last thing that I think you'll find interesting. Don't take this to heart because I don't think it makes too much sense, and there's not really a great explanation for why this even is, which kind of suggests it would be something wrong with the study, but apparently fluid intelligence, so can you kind of solve problems, can you recognize patterns, is correlated with your baseline pupil size. So the way you measure fluid intelligence is basically you give people things like this. So you see the half-colored circle, half-colored thing goes on there. Your job is to basically just complete the pattern. So as the pattern is like one half filled, and then all full, the answer would be this one here, which is all full, right? And notice the other two are two triangles or 4 triangles, 2 each. That's why you also have 2 triangles here. So it's pattern recognition, essentially, kind of meant to be a measure of fluid intelligence. People have found that baseline pupil size is correlated with fluid intelligence. So it could indicate better neural connection. And I'm not sure how they did this, but they did control for things like effort, stimulus familiarity, drug use, and there was a couple others. So I don't know. I mean, I read this study a while ago. I couldn't initially find any problems with it or confounds, but I don't know, it just doesn't, the explanation they gave for why this would be the case is really not, really wasn't that good. So I found it kind of hard to believe, but you never know, could be true. Point is, don't bother staring at people's pupils and trying to guess how smart they are. Okay, so that's it for today. So kind of takeaway messages, lots of different ways to measure and research attention. They all have their pros and cons. Eye tracking can be really useful in some situations where, especially like a natural environment where you don't want to maybe have people doing some sort of task. Maybe you just want to have them enter, an environment and see where they look freely. But eye tracking, of course, has its problems too. It's not a perfect measure because where you look is not always necessarily what you're attending to. And of course, the reverse, I guess, also on that note, remember with change blindness, the idea that we see everything is kind of a cognitive illusion. Only can really focus on one thing at a time. And our attention does typically compensate for this in various ways, but it's not always perfect. And sometimes you even miss a change right in front of you. Okay, until next time. Oh, I should have your abstracts and first lab reports done. If not today, then tomorrow.